Great, I'm on. Hello all, I'm Dave Ojha. Today I'm going to talk to you about how can we stop linking our on-chain identity together. So the sketch of this talk is going to be first going to kind of motivate why does privacy matter and why we need to stop having correlated identity for everything. Then going to go through some examples and sketch here's some example Osmosum contract we have, and how can we make that private with minimal code changes for developers. Then I'll kind of explain to you how Zcash works, and finally show you what the API is doing under the hood. So let's get started. First, is one of my favorite slides from Ian Myers. Cryptocurrency today is like Twitter for your bank account. All your spending is made public to everyone forever, and you just can't get around this today. So we're directionally getting worse year over year as well. We're trying to reinvent governance here. A very exciting prospect, except, all your votes are linked together forever. And, we started doing these ENS and ICNS things. So, you have Zach XBT and Chainalysis already knowing that these set of addresses are you. And great, with ENS and ICNS, I've basically labeled it for them. This is the real human I am. And the same is true for NFT profile pictures. Moreover, we're just generally incentivizing people to dox themselves with how we make airdrops. Today, where airdrops are paying you to use the same address for everything. So we need to start getting tooling in place on chain to really start correcting this sooner than later. And really, this isn't just some abstract problem. If we split lunch together, I'm not going to pay you back on chain today because I don't want to leak to you my entire transaction history. And this is bad. I want to be dog fooding crypto for payments by using it for everything. So we really need to get this fixed. So if we put on our protocol designer hat, how do we fix this? So we already have very smart people at Zcash, Aztec, Penumbra, Anoma, making these tools for the payments. You heard how we can bootstrap payments to make shielded swaps from Adrian earlier today. But we actually need more than just that. So I'm going to start with some examples. OK, payments, whatever. Voting, I think I explained a minute ago. Then identity, there's some bad kids NFT party tonight. You have to dox your address to get in. Literally overheard at WeWork. Someone's not going to go because they don't want to show their address with 5 different bad kids. They just want to show proof that they own one. Similarly, the one I'm going to hone in on more today is for DEX trading tiers. So in Osmosis governance a couple, maybe 1 or 2 months ago, we voted on this proposal where the DEX is going to have a protocol swap fee. And we alluded that in the future, we should have the swap fee go down with more volume you do. But there's a problem here where, imagine Namada shielded swaps. All your swaps are coming from a Z address. But if you do a different Z address every time, which is kind of the point, to be unlinkable, your volume per month for this, what is your volume tier, is always going to be the worst tier. This is bad. Then we've made some financial incentive again to not be private. And so then the goal is going to be how can we make, with this trading tier thing as an example, how can we get this to be private? How can we make your volume per month be privately updated, and you only reveal which fee tier you're in, and nothing else. So the one intuition here is all of these things, voting, identity, I guess it's in the name, and this DEX trading tier, is trying to basically make some new identity for you for that application, whatever that app dev wanted to do. So yeah, I guess how do we make this private? So this key idea maybe is that we already write these smart contracts in the lens of accounts. That means is you have some public key or some address, and you have some metadata attached to that address that's public today. Hey, and so let's go into the code for an example. This is this protocol fee tier. Oh, cool. This ends up being readable here. Well, let me annotate this a little bit. So what is this code doing? It's it's a standard Osmosum boilerplate. But then we have some message. First, we parse. The message here is going to be a swap. So a swap, even with a shielded swap, has some amount in and some slippage. And then what we're going to do is we're going to say, get your fee tier account, or get what is my current volume per month for this address. and then like increment that by my new swap's volume, save that in state, and then take the volume per month I have, figure out which fee tier I am, charge that fee tier, do my swap. This is kind of this transparent code we have. And what we'd like to do is hide this volume per month, right? Because if we assumed we had shielded swaps, this is where the leakage is coming. Because we're making the volume per month public, we're now making this, this is what's causing the address doxing. So here's the ZK API I'm like proposing that, or I'm going to state is achievable and convince you later. Well, it might have actually been hard to see the difference, so let's just circle it. The idea is the difference should really just be these change these types for these math operations to some ZK types that then in the back end do something different for on-chain code for what you're doing on-chain and client code for making the transaction. So and you just need this to be tracked consistently, but it looks basically the same for the app developer. So the complicated part is this private get fee tier thing is natively it was very clear. We just kind of get there's some object in state linked by your address, get it. And in the shielded setting, we're up to something a little bit more complicated, but I'll explain that in a little bit. But at the API level, nothing has to change. Then there's one other line here, this fee bips to get output. OK, that's that is one oddity. You have to mark what is the ZK variable you want to be public for everybody. So how do we do this? This is going to be a technical interlude of basically explaining Zcash in 5 minutes. You can kind of skip the next. You can understand everything else without this, but I think it's interesting. And yeah, so if you know Zcash, just replace the word account with note. You are now at Zcash. OK, so every user has an identity description, some account with the public key and some metadata. What is this metadata? Well, if I'm doing payments, the metadata is going to be 1 Bitcoin, if whatever my balance is. And for these swap fee tiers, it's just going to be my volume per month. And the public key can get pretty complicated, especially if you want account abstraction. I'll show a slide at the end just for how Zcash does it. I think we actually want it to be even more complex. Mata is doing stuff for that. So OK, how do you make something private? Idea one, just make a list of accounts. Really a Merkle tree, whatever. Make a list of them, and just post these on chain. Just list of every account hash. And then when I want to go do something, I want to spend some I want to do a shielded to public spend of half a BTC. I'm going to do a zero knowledge proof that I know some account in this list, and the account I know the private key for the account for that account's public key. That account has permission to do this action. So permission for spending half a Bitcoin is having balance greater than half a Bitcoin. And then my account updates this new account. So the zero knowledge proof kind of tests all of this. And so for this payment, your new account, if I spent 0.5 BTC, and I had one at the beginning, is also new account is 0.5 BTC. So and then idea, let's update the account list for whichever account you are to be whatever you mutated to. Well, OK, there's a clear problem. Well, OK, updating it told you which account I was. OK, so how do we fix this? Idea two, just append that new mutated account to the list of a list of accounts. OK, which works. But new problem, you can reuse account 2. We have to make some way to make account 2 unspendable now without leaking that it was account 2. So this is the idea of replay protection, where in Zcash we call these nullifiers. Really, it's just we have some unique number associated with every account. And if you can't go from that number to figure out anything about the account, basically every account has some random number inside of it that no one sees transparently. And whenever you go do an action, you just have to publish the nullifier for the account. So no matter what you do, if I spend 1 Bitcoin or half a Bitcoin, or if I go vote in some governance proposal, whatever, they all produce the same nullifier. And so then in your zero knowledge proof, we amend the steps from before to also have reveal the nullifier. And then every full node on chain basically just says, have I seen this nullifier before? You keep all old nullifiers in state, and then you just check against that. And basically, this is what stops refake protection. If we, so if we zoom out a bit before we go back to the API, hey, what's going on? To do a shielded action, I just say, I know some account. It has permissions to do something. And, OK, I update the permissions based on whatever I did. And save that new account to state, mark the old account as impossible to use via nullifiers. So that kind of ends the technical interlude. And let's go back to what could this API look like. Well, OK, here's the ZK API. Hey, well, we need some sort of compiler stack to basically look at this code and do something different on-chain in the client side. So what do we need? Well, OK, we need to kind of on-chain for getting these accounts. You need the get accounts to verify this Merkle proof that there's some account in state, and you need to kind of build the ZK circuit correctly. But building the ZK circuit can just be done with these API calls, where get and set are telling you what is the variables you've mutated that should be set in state. And all these ZK-I32 stuff is just what are the operations you do in your zero-knowledge circuit for showing that phi bips was computed correctly. So this is all just circuit building that you don't actually have to surface to the developer. As a developer, you can just write your normal code and with very minimal transformations here. OK, I guess skip that. So yeah, we're basically achieving the goal of letting you get ZK private actions on chain for any app you want without much of a code change. OK, ignore text. So basically, I'm ignoring this big problem. How do you make clients and front ends for all of this? But it's really just a library problem. We can just do it once. And you can start with a bad solution and improve it over time. We don't need to get this perfect the first time. We're already at an amazing goal of getting on-chain privacy, and if we leak to a full node in the beginning, and we can just over time, we know the cryptography tricks. It's just a matter of getting them faster. They don't need on-chain changes. So if we get people on this on-chain library already, we can start really iterating on getting full privacy for this stuff. So thanks for your time. If you have any questions, please just come find me. Twitter's at @ValorDragon. If this is interesting stuff to you, reach out. I'd love to find people to collab on to build this stuff. I think getting privacy for app devs is really achievable. Thanks all.